This is the midterm review for Operations Management 726, and we are doing sample problem 6, which is a cost of quality problem. So we have 3 tasks, and each task variable cost is added to the product. This could be labor and raw materials, and unfortunately for this company, they do not have perfect quality, so only so many of the products that they make at each step are good. And so these are the yields at each of the steps. So what the question asks is basically, what is the variable cost of a good unit? And inspection in this first problem is done at the end of each step, and defective units are completely scrapped. We're assuming that they can't be reworked, that they get thrown away. Okay, so at task 1, we put $5 worth of materials and labor into each part, but unfortunately only 96% of them are actually good. So what happens is the 4% that get thrown away, so 4% at $5, that money that we put into the variable cost actually gets saddled on to the good ones that made it through, because we've got to account for those costs. So the real variable cost of a good unit, therefore, at the end of this process, we do the math by doing $5 and then dividing by 96.96, and this results in a higher $5.21 variable cost for the good products that came out of step 1. Okay? Now what happens is those good products go on to step 2. So we have $5.21 coming into step 2, and at that point we add another $3 worth of value to the product. So it has a cost of $8.21 coming out of step 2. The problem is that only 97% of these units are good, and so therefore we have to do the same thing. We divide by $8.21, we divide by 0.97, and those products end up having a variable cost of $8.46 at the end of step 2. The $8.46 per unit is what it goes at the start of step 3. We add another $2 worth of labor to it, so that means each unit has $10.46 worth of input and labor up to that point, and again, not 100% go through, only 98%. So we have to again account for that loss by dividing by 0.98, and this gives us a final total variable cost of $10.68 per unit. This is the answer to the first part of the question, which is, what is the variable cost of a good unit? $10.68. Now, the question goes on to ask, if you started out with enough material to make 1,000 good units, and the selling price is $20 per unit, what is the effect of the less than perfect quality on contribution? This is kind of a tricky problem, but you probably will see something like it on the midterm, so I suggest that you practice a couple of these. You can get together with colleagues and make up your own sort of numbers. So what this is asking is, this is saying, if we start out with 1,000 and we had perfectly good quality, what would we make for contribution? Well, we would have 1,000 units to sell, and we're going to sell them for $20, but it costs us, if we were to add up these numbers, 5 plus 3 plus 2, that would be $10 if we didn't have any quality problems of total variable cost. So what we would make in profit would be $20 of the selling price minus the $10 of the variable cost. So we would make $10,000 if we had perfect quality, okay? But we don't have perfect quality. We don't have perfect quality. Instead, what we have is, out of the total process, we only get 0.96 times 0.97 times 0.98. This is the total yield, which turns out to be 0.9126 is our final yield from the whole process. And so what you have to remember with yields is you multiply them to get the final yield. The way of thinking about it is, after the first step we have 96% are good, but of those 96, only 97% are good. So that's 96 times 97. And of those that are good, only 98% of those are good, so we multiplied by the 98% again. So if we started out with 1,000, but only 0.9126 are good, we would end up with 912 good units that we could actually sell at the end of the process. And what is our contribution margin? Well, we sell them for $20, but now our total variable cost is $10.68. So we're making less on each, so we're making fewer good products we can sell, and each one we sell we're actually making less money on. What we're making on it is $9.32 times 912, and this would give us $8,499.80 instead of this $10,000. So the difference between those two numbers, between 10,000 and 8,499, is equal to $1,500, basically 0.20 cents if you want to include that, less contribution. That is the cost of poor quality, $1,520. So this is the cost of poor quality. Okay, the big assumption in this problem was that, and we stated it right up front, that inspection is done after every step. So what you need to know, because this is what we'll ask you, is, well, what if inspection was only done at the end of the process? What is the difference in this cost of quality contribution? So let's erase these numbers and let's look at this with the inspection only at the end of the process. So we get rid of all of this up here. The final yield stays the same. So now what happens is, after task 1, $5 is added. Actually, only 96% of them are good, but we don't do any inspection. So all 100, including the 4% that were bad, move on to step 2 and get $3 more added to them. And then only 97% of those are good, but we don't do any inspection. So all of those, including the defective ones from step 1 and the defective ones from step 2, all move on to step 3 and get $2 more added to them. Only 98% of those are good. It is at that point that we do the final inspection. So we have $10 total in variable cost added to every single unit, but we have to divide by this final yield of 0.9126, because that's the percentage that we have good. And it turns out that that total variable cost number, so this is equal to $10.96. This is the total variable cost when inspection is only at the end. So that is greater than it was when we had inspection after every step. So what is the cost of quality going to be? Well, we would still make, if it was perfect quality, we would still make the $10,000, so we can leave those calculations here. We'd still only get 912 good units. But now, instead of $10.68 in the variable cost, it's actually costing us $10.96. So the total market money that we make, right? So let's erase these numbers. So then the per unit contribution is $9.04 times 912, and that turns out to be $8,244.50 that we make. So the cost of quality is the 10,000 minus the 8,244.5 for $1,755.52 less contribution due to the cost of poor quality. So that's the answer if inspection was only at the end. And what you need to be able to understand and explain is, why is there a difference between those two numbers? Why is it more expensive to do inspection only at the end? And it's because you continue adding value to products that are defective if you only inspect at the end. And that is the reason. Thank you very much.